Hello, awesome Algebra 1 students, and welcome back. In this short video, we are going to be reviewing factoring special cases. So there's two types of special cases. The first one is called the difference of two squares. The way that you can tell if it's a difference of two squares, one, it must be a difference, meaning it's subtraction. Two, there must be two terms, aka a binomial, and both of those binomials must be perfect squares. If all three of those are true, to factor it, all you do is you take the square root of both terms and you place it into this form. So the square root of a squared would be a, square root of b squared would be b. So you would have one where a is minus b and the other where it's a plus b. The reason for that is you'll notice there is no middle term. So if both of these were adding, there would end up being a middle term, or if both of them were subtracting, there would be a middle term. So by having one as subtraction and one as addition, that ends up creating a zero term, and that's how you end up with a difference of two squares. The other one is called a perfect square trinomial. This one is harder to tell. First thing, it must be a trinomial, meaning it has three terms. Similar to difference of two squares, the first and the last term are both perfect squares. The middle term, however, has to be double the product of the square roots of the first and the last term. So in other words, I take the square root of the first and the last term, and then I add that up to itself, or I double it, and that should equal the middle term. If that's the case, it ends up factoring into a binomial squared. Same thing here. The only difference with this one is that it is subtraction. So my binomial ends up with subtraction. So we're going to look at a couple of examples using a worksheet practice. All right, so in all of these examples are either difference of two squares or perfect square trinomial. So again, the way that we can tell is does it have two terms or does it have three terms? So the first one is our difference of two squares. So looking at number 19, the first thing that I notice is yes, it is a difference. And both terms, v squared and 25, are perfect squares. So to put this into its factored form, I'm going to take the square root of the first term and the square root of the second term. The square root of the v squared is v, because v times v is v squared, and the square root of 25 is 5. So my final answer will be a product of two binomials. To create a middle term of 0, one will have addition, the other will have subtraction. The first two terms in these binomials multiply to get v squared, which is v and v. And the second two multiply to get 25, which is 5 and 5. Now, if we do a quick check by multiplying, you'll see that v times v is v squared, 5 times negative 5 is negative 25, and positive 5 plus negative 5 is 0, which is why there's no middle term, and that's the fully factored form. So if you can identify that this is a difference of two squares, it's actually a lot simpler to factor than if it wasn't. Okay, number 20, we have 9x squared minus 1. Is it a difference? Yes. Are there two terms? Yes. Are both terms perfect squares? Well, I know 9 is a perfect square, and so is x squared. The square root of 9 is 3, and the square root of x squared is x. So the square root here would be 3x. Now, what a lot of students struggle with is they forget 1 is actually a perfect square. The square root of 1 is just 1, because 1 times 1 is 1. So yes, this is a difference of two squares, meaning I can set up my factored form. One will have addition, the other subtraction. This time I'll change it just because, again, it doesn't matter. You can do addition first, subtraction second. Square root of the first term is 3x. So in my binomials, my first terms will be 3x. And the square root of the second term is 1. So in my binomials, I end up with 1. Let's do a quick multiply to check here. So 3x times 3x is 9x squared. Negative 1 times positive 1 is negative 1. And if I were to multiply, I'd end up with 3x and negative 3x, which if you add those two together, you get a zero term. So I know I have factored this correctly. So again, a difference of two squares is actually worth thinking about because it's a lot simpler to factor. Okay, let's take a look at 23 and 24. So these are trinomials, meaning it can't be a difference of two squares, but it could potentially be a perfect square trinomial. So here we go. First thing, is it a trinomial? Yes. Are the first and last terms perfect squares? Well, 25n squared is, and so is 1. Yes. So now we test the middle term. So the square root of 25n squared is 5n, because 5 times 5 is 25, and n times n is n squared. And the square root of 1 is just 1. Now, to check the middle term, you multiply these two together. 5n times 1 is 5n. And then you add that to itself. 5n plus 5n gives you 10n, which is the middle term. So yes, this is a perfect square trinomial. So because it's a perfect square trinomial, it very simply simplifies into the square root of the first term. Because this is an addition sign, it's a positive 10, plus the square root of the second term squared. And you're done. Because 5n squared is 25n, 1 squared is 1, 5n times 1 is 5n, which if you were to double, you'd get 10n. It's crazy to think that you can factor something like that in that short amount of time. Let's look at 24 because it does have subtraction, which means it changes slightly. So here we go. Is it a trinomial? Yes. Is 49n squared a perfect squared? Yes. Is 25 a perfect squared? Yes. Now we need to test the middle term. So we take the square root of the first term and the square root of the last term. Square root of 49n is 7n, because 7 times 7 is 49, and n times n is n squared. Square root of 25 is 5. So we're going to multiply these together. And that gives us, let's see, 7n times 5 is 35n. And then we're going to add that up, 35n. And that gives us 70n, which is the middle term. The only difference here is because it's subtraction. We would have to account for that in our final answer. So yes, this is a perfect square trinomial, which means our final answer is very, very simple. It's going to be a binomial squared. The first term will be the square root of the first term, so 7n. Subtraction, because these add up to a negative middle term, and the square root of the last term, 5. Ta-da! Done. Let's see if that adds up. 7n squared is 49n. 5 squared is 25. 7n times negative 5 is negative 35, which if you were to double, you get negative 70. Bada bing, bada boom, we are done. So again, just as a reminder, difference of two squares, it must be a difference of two terms, both of which are perfect squares, and it always factors into one positive and one negative because that middle term is 0. In a perfect square trinomial, only the first and the last term are perfect squares. The middle term you have to test by taking the square root of the first and the last term, multiplying them together, adding them up, which is definitely a lot more work here, but it's a lot easier than trying to do one of the other factoring methods. That's it for factoring special cases, and have fun.